Hey everyone, I hope you're doing well today. In this video, let's simplify down the process of solving absolute value equations. For this first example, let's try solving the equation the absolute value of m is equal to 14. Because the absolute value bar is already isolated on one side of the equation, in one scenario, we can say that m could equal positive 14, and in another scenario, we can say that m is equal to negative 14. Because the absolute value of negative 14 and positive 14 are both equal to 14, both of these solutions work. Therefore, we can say the solution set here, or the numbers that make this equation true, are when m is equal to negative 14 and m is equal to positive 14. There's our solution set. For example 2, we have the absolute value of negative 7a, and let's say that is going to be equal to positive 28. Once again, since the absolute value bars are already separated on one side of the equation, we can go ahead and write two separate equations and say that negative 7a is equal to positive 28, and then say that negative 7a is equal to negative 28. For solving equation 1 on the left, let's go ahead and divide by negative 7 on both sides of the equation, and when we go ahead and do that, we're going to get 1a on the left, or just a, is equal to negative 4. And on the right side, if we do the same thing and we divide both sides by negative 7, we're going to see that we're going to get 1a, or just a on the left side, and negative 28 over negative 7 is going to equal positive 4. So the two solutions, or the two values for a that make this equation true, are going to be negative 4 and positive 4. Those are our two solutions. For example 3, let's try the absolute value of negative 2v minus 5. And let's set that equal to positive 17. Once again, our absolute value bars are isolated on one side of the equation, so we can go ahead and separate into two equations right from the beginning. One scenario, we have negative 2v minus 5 is equal to positive 17, and in another scenario, we have negative 2v minus 5 is equal to negative 17. Solving the equation on the left, let's go ahead and add 5 to both sides of the equation using the addition property of equality. And when we do that, we're going to be left with negative 2v plus 0, which we don't have to write, and that's equal to positive 22. If we go ahead and divide both sides by negative 2 using the division property of equality, we get positive 1v, or just v, is equal to negative 11. For equation 2, we're going to solve similarly by adding 5 to both sides of the equation. And when we go ahead and do that, you're going to see that minus 5 and plus 5 will cancel out, and we'll have negative 2v is equal to negative 12. Then using the division property of equality again and dividing both sides by negative 2, we get positive 1v, or just v, is equal to positive 6. The two values of v that make this equation true are when v is equal to negative 11 and when it's equal to positive 6. Those are our two solutions. For number 4, let's try the equation negative 2 times the absolute value of z plus 3. And let's say that's equal to negative 14. When we have an equation like this, don't separate into two equations just yet. Remember, we need the absolute values to be alone on one side of the equation, so we have to get rid of this negative 2 first. Since negative 2 is multiplying by this absolute value of z plus 3, let's go ahead and divide both sides by negative 2 using the division property of equality first. Once we divide both sides by negative 2, we're going to be left with the absolute value of z plus 3 along the left side of the equation, and on the right side, negative 14 over negative 2 is going to equal positive 7. Now that we have the absolute values isolated on the left side, we can separate into two separate equations. For our first equation, we can write that z plus 3 is equal to positive 7, and for our second equation, we can write that z plus 3 is equal to negative 7. Solving the equation on the left, we can use the subtraction property of equality and subtract 3 from both sides, and those 3's are going to cancel out, so we find out that z is equal to positive 4. For the equation on the right, we're going to use the subtraction property of equality again and subtract 3 from both sides of the equation, and we're left with z is equal to, and I think that's going to be negative 10, since negative 7 minus 3 is the same thing as negative 7 plus negative 3, and that's equal to negative 10. The two values that make this equation true are when z is equal to negative 10, and when z is equal to positive 4. Those will be our two solutions here. For number 5, let's try solving the equation the absolute value of 2w minus 4, and let's put that whole thing on top of 6, and let's set that equal to 3. Again, when we look at this type of equation, don't separate into two separate equations first. Notice how the absolute value is dividing by 6 on the left side, and we need to get rid of that first before we can separate into two separate equations. Using the multiplication property of equality, let's go ahead and multiply both sides of the equation by 6 to isolate the absolute values. So notice how these 6's are going to cross cancel on the left side, and we'll be left with the absolute value of this 2w minus 4, and that's going to be equal to the right side, which is going to be 3 times 6, or the same thing as 18. Now that we've isolated the absolute values, let's write two separate equations. Because the absolute value of 18 and negative 18 are equal to 18, our two scenarios are going to be 2w minus 4 are equal to positive 18, and 2w minus 4 is equal to negative 18. For the equation on the left, let's use the addition property of equality and add 4 to both sides. And when we do so, we're going to get that 2w is equal to positive 22. And using the division property of equality, let's get a coefficient of 1. Let's say that 2w divided by 2, that's going to be just 1w, or w, and 22 divided by 2 is 11. For the equation on the right, let's go ahead and use the addition property of equality again and add 4 to both sides of the equation. And when we do that, we're left with 2w is equal to, that should be negative 14. And then using the division property of equality, we can divide both sides by positive 2, so we get a coefficient of 1, and say that positive 1w, or w, is equal to negative 7. The two values that make this equation true are when w is equal to negative 7 and when w is equal to positive 11. And that'll be our two solutions. For example 6, let's try the equation negative 10 times the absolute value of h plus 5. That's going to be inside the absolute value. And let's take away 3 along the outside and set that equal to negative 83. Before we can write two separate equations, we need to get rid of this minus 3 and this negative 10 that's multiplying by the absolute value. As usual, we'll start with the addition property of equality to move that minus 3 to the right side of the equation first. And once we go ahead and do so, we're going to be left with negative 10 multiplied by the absolute value of this h plus 5. And that's going to be equal to, I think that's going to be negative 80 on the right side of the equation. Now to get rid of the negative 10 that's multiplying by the absolute value of h plus 5, let's go ahead and divide both sides by negative 10 using the division property of equality. And you're going to see that these negative 10s will cross cancel on the left side, and we'll just have the absolute value of this h plus 5. That's going to be along the left side of the equation. And on the right side, we have negative 80 over negative 10, and that's going to equal positive 8. Now that the absolute value is isolated on the left side, we can separate into two equations. In one scenario, we can say that h plus 5 is equal to positive 8, and in another scenario, we can say that h plus 5 is equal to negative 8. Solving the equation on the left, let's use the subtraction property of equality and subtract 5 from both sides of the equation. And when doing so, we're going to get that h is equal to positive 3. And for the equation on the right, let's go ahead and subtract 5 from both sides again. And when we do so, this h is going to be isolated, and we have that h is equal to, and negative 8 minus 5 is the same thing as negative 8 plus negative 5, and that's equal to negative 13. So the two values that make this equation true are when h is equal to negative 13, and when it's equal to positive 3. Those are our two solutions. For example 7, let's try 3 over 2 multiplied by the absolute value of 4r minus 4. Let's take that whole thing, and let's go ahead and take away 24 from that, and set that equal to negative 21. Before we separate into two equations, let's get rid of this minus 24, and this 3/2 that's multiplying by the absolute value. Using the addition property of equality, let's go ahead and add 24 to both sides of the equation. And when we go ahead and do so, we're going to find that we're left with 3 over 2 multiplied by the absolute value of this 4r minus 4. That's going to be on the left side of the equation. And on the right side, negative 21 plus positive 24 is going to equal positive 3. Now to get rid of this 3 over 2 that's multiplying by the absolute value, let's go ahead and multiply by the reciprocal on both sides of the equation, because that will get 1 and it will no longer be on the left side. So this 2 and 2 will cross cancel, the 3 and 3 will cross cancel. So on the left side, we're just going to have the absolute value of that 4r minus 4. And that's what we wanted. We got that alone along the left side of the equation. And on the right side, just keep in mind that this 3 is really 3 over 1. That can cross cancel with this 3 as well. So on the right side of the equation, we just have 2. Now that we've isolated the absolute value, our two separate equations are going to be 4r minus 4 is equal to positive 2, and 4r minus 4 is equal to negative 2. Solving the equation on the left, we can start by adding 4 to both sides of the equation, or using the addition property of equality, and we'll be having 4r is equal to positive 6, and then using the division property of equality and dividing both sides by 4, we find that r is going to be equal to 6 over 4, or 3 over 2. For the equation on the right, we'll start by adding 4 to both sides of the equation, just like we did earlier, and we're going to be left with 4r is equal to positive 2, and then dividing both sides by positive 4, we're going to find that 1r, or just r, is equal to 2/4, but that simplifies down to 1/2. The two values that make this equation true are when r is equal to positive 1/2, or when r is equal to positive 3/2. Those are our two solutions. And just to show you two special cases that you need to be aware of, let's try for number 8 solving the absolute value of x, and let's set that equal to, let's just say, negative 6. If you ever see an absolute value equation that looks like this, where we have an isolated absolute value on one side and a negative value on the other side, make sure you stop and think about what's actually happening here. It's important to remember that whatever comes out of an absolute value has to be positive, since it's measuring its distance from 0. No matter what number we put in for x, we can't get a negative 6 to come out of the absolute value. When we have equations like this, make sure you go ahead and say that there's going to be no solution. One final example to take a look at is if we have negative 3 times the absolute value of 2x plus 1, and let's go ahead and set that whole thing equal to positive 21. Well, at first glance, it looks like this equation can be solved because of the positive 21 to the right. Remember, we have to isolate the absolute value and get rid of this negative 3 first. Since negative 3 is being multiplied by the absolute value, let's go ahead and use the division property of equality and divide both sides by negative 3. In doing so, we're just going to have this absolute value of 2x plus 1 along the left side of the equation, and on the right side, positive 21 over negative 3 is going to equal negative 7. Just like in example 8, notice how the absolute value is isolated on one side, but it's equal to this negative 7 along the right side. Make sure at this point, you stop and go no further, and you go ahead and say that there's going to be no solution for this particular equation. There's your answer. Hopefully, you found this video helpful in better understanding how to solve absolute value equations. If you did, feel free to give the video a thumbs up and let me know in the comment section down below. And if you're taking a quiz or test on these types of equations, you're going to do absolutely amazing. As always, keep up the great work, and I'll see you in the next one.